This is the program loops example from your Canvas page. So this program is going to go through and show you an example of how to use a loop to create a data table, and then we'll also look at how to use a class to do the calculations, and then we'll deconstruct it a little bit and also look at how to change the class over to just using a function, and then we'll deconstruct it a little bit further and show you how to just enter your equations right into the loop. I would recommend as you're programming though, try to see if you can use a class for the program that you're working on, and so try to use this kind of as your example program. So we've got IO stream, we've got IO manip because we're going to do a data table, and in this one we're going to use CMath because we're using these trig functions. One thing to always keep in mind with C++ is that trig functions always use angles and radians. So we're going to need pi to be able to convert, but pi is not a built-in in C++. So let's declare it as a constant. So CNST will mean that it's a constant. We'll use double so that we have plenty of digits, and then we'll just do pi lowercase pi equals and put a semicolon at the end. When you're declaring a constant, usually you want it to be a global constant. So global means that all of the functions in your program can use it. And so that means that you need to put it outside of all your functions. So notice we have our include statements up here, and then we have our constants just right underneath our include statements, but before we have any of our functions. Now with this program, again, this is a fairly short program, so if you have a really long program, you might package all your functions and classes into a separate file. But in this case, we just have a couple of functions in this main class. So we're going to do our function just right up here before main, and then we've got our class, and then we've got main down here. So why don't we start in main, and then we'll go back up and take a look at what's going on in the class. So this program is going to print out welcome to the trig function angle generator, and then it'll ask us for a starting angle and then an ending angle, and how many data rows do we want. So let's run it and see that. So we want a start angle of, say, 0. We want an ending angle of 90, and let's say we want 91 rows. So that'll give us the first row is 0, and then it'll just advance through until 90 degrees. And so this program is creating these data tables. Let me scroll up and we'll look at this very first data table that's being created. So the first data table is with a for loop. We're setting the angle, and then we're calculating sine, cosine, and tangent. So let's see how the program is doing that. So we have this equation, dag underscore increment. That's going to be the increment in the angle as we go through, and this one's in degrees, so we're going to have to convert it. So this is going to be equal to our final angle minus our initial angle, so final minus initial, divided by the number of data rows minus 1. You'll see this double in parentheses. The reason that we have that in there is that data rows is an integer, and so it should go ahead and get promoted to a double because the numerator with this calculation is a double. But just to make for sure, we can put the keyword double in parentheses, and then once it does this data rows minus 1, then it'll force promote it to a double before it does any of the rest of the calculation. Again, it shouldn't matter. It should go ahead and do it correctly anyway, but it's not a bad idea just to put it in there as a reminder that it's doing this. And then we're going to go back and create an instance of our class. So our class is called calculations, and then our instance of the class is called myCalc. We're not giving it any argument here. We're not passing it anything, so it's going to use the default constructor. We'll go back and take a look at that in just a sec. And then it's going to set the current angle equal to the initial angle, so that would be 0. And then it's going to print out for loop, and then data table, and then it's going to print out this header. Notice that the header, angle, degree, sine, cosine, tangent, goes outside and on top of the for loop. And then since we're going to create a table, we want it to always have the same number of decimal places as we go. So we're going to send it that std fixed, so that's that fixed format flag to make it show the decimal in fixed notation, and then we're going to do set precision 5. So since that follows fixed, we're going to get 1, 2, 3, 4, 5 places after the decimal for each of these numbers. Once you set this once, then it's in there, and every time you print out, it's going to continue with the fixed flag set and the set precision of 5 set. Unless, of course, you print something that's not a double or a float. So like if you printed an integer, then the fixed and set precision shouldn't affect the integer or character or a string. So here's our statement to print it out. We've got all of our formatting in here. So we're going to do our instance of our class, a myCalc. We're going to execute a function out of this, so change angle. We'll give it current angle, which we set to 0, and then we'll see out all this stuff. This is all one single line that ends here on line 107 with the semicolon. So we're going to see out a set W, so remember that's a set width. So this first spacing here where this 0 printed out is going to have a column spacing of 11. And that's going to give you current angle, and that column spacing is going to be the same all the way down. So that's going to keep that decimal lined up all the way down. And then we'll do a set W9 and print out the next column, and then a myCalc.getSine, set W9, myCalc.getCosine, that prints it out, set W9, myCalc.getTangent, that prints that out, and then we'll print out a final inline character here to finish it off. Now we need to increment that angle though before we go for the next row. So current angle is going to be current angle plus the degree increment that we calculated way up here. So that's going to then change the current angle to 1, and then we're going to print out the whole thing over again. Now on your program, I would really strongly recommend that you use a for loop. But just for completeness, let's take a look at a while loop and a do while loop. So here's our while loop output, and let's see how that would be different. So we reset current angle, we have to initialize j, and then we do while j less than data rows. We have to manually increment j up here because it's not part of the while statement. The internals of the while loop look exactly the same. But there's just a lot more opportunity for error because you have the setting up of the variable and the incrementing of the variable in separate lines from the testing. And let's look at the do while loop. So scrolling down, you can see the do while loop gave us exactly the same output. We have to again set up a new variable, reset the current angle, and then we have our do, increment our variable, do all our calculations, print them all out, and then do our test again. Remember, with the do while loop, the test always comes at the bottom. Okay, so now let's change or start working on changing our program. So let's say that you're working on your programming 4 assignment, and let's say you want to use this kind of as an example for this. So let's get rid of these extra loops because we really only need one loop in here. So let's leave our while, our for loop in here. Let's get rid of our while and our do while loop. Let's run it again just to make for sure that everything works, that we didn't mess anything up. Okay, still looking good. Oh, one last little thing. You might notice that this number looks a little bit off. That is because it is the tangent of 90 degrees, which is infinite. But the good news is C++ has that protected. So even though it's an infinitely large number, it's not going to actually return an infinitely large number. It's just going to return a very large double. So it won't cause any kind of overflow error or cause your program to stop running if you do a trig function and the trig function just happens to be infinity. Okay, so now let's take a look up in our class and see what we would need to change if we were thinking about changing this over for program 4. So we've got our function that stands alone up here, and all our function does is it just converts degrees to radians. So you give it an angle in degrees, it does the calculation, pi times the angle in degrees divided by 180, it returns that as a double. So that's fine, we don't need to mess with that any. In calculations, we have these private variables, so these are just the variables that we're doing. So when you work on program 4, you could change these to be the variables that you're trying to calculate for that projectile motion. And then in public, we have the functions that it's using. So we've got calculations, which just creates an instance of our class. You might use calculations to calculate the part of the functions that are not going to be time dependent. You could put all of those down in here if you wanted to. The difference though for you is that instead of just using a default constructor, you would want to change this so that it has double and it has each of the variables that you're getting from main and passing them up to here. So let me change this back to void just because I don't want to break the program. And then you could keep then this void change angle. So this change angle is changing the angle and it's recalculating everything. You could change this to where this is change time and it's receiving a new time and then it's just recalculating, and then all your formulas would then go right in here into this change time member function of the class. And then the rest of these functions are just getting these values. So they're just returning the private variables that were already calculated up here. So hopefully this kind of gives you an idea of how to get started with this. But let's say that you're not quite ready to do a class. How could you do this just with all functions? So let's take a look at that. So let's remove class calculations, but let's leave this part so that we can turn it into functions. No, we don't need this part. This was part of our class, so we can delete this. We're not going to need this change angle because we're going to have to recalculate it each time. So this get sign, we'll do an open close parenthesis, open close brace after get sign. We'll do the same thing after get cosine, and then we'll do the same thing after get tangent. So on get sign, we'll do this portion of the calculation. With cosine, we'll do this portion of the calculation. We're just moving them up and we'll fix them in just a sec. And then tangent, we'll do this portion of the calculation. We probably want to do the radians once down in the program, or we could go ahead and do that in each of these. So let's just go ahead and dump it in here. I need to dump it in here above the value that's being calculated. Okay, so I've got everything there, so I can delete this. We're going to be doing this a different way, so I can delete all of this. I can delete this, and I can delete this. So let's make these functions work, and then we'll go back down in main and fix main so that main's working. So I need, in order to get a value for sine, I need a value in degrees. So I'm going to change this void to be double because I need to receive that value in degrees. So I'm going to do d. And then instead of doing this calculation like this, I'm going to go ahead and just take this out, and I'm going to run this function inside of here. So I'm going to do degrees to radians, send it d, and then that'll get then passed to the sine function that's a library function, and then it'll return that value. I don't really even need to do sine val here. I haven't declared it yet. So instead of doing that, I could just do a return here. Let's set these up the same way. So instead of cos val, I'm just going to do a return. I don't need the equals because this is the value that's being returned. And then I need to give it this degrees to radians, which means I need to receive that value up here. And then let's make the same changes to get tangent. So it's going to receive a value in degrees. Let's send it to the tangent function from the library, and then let's return that value. So it's possible that I made some syntax errors because I've changed a whole bunch of stuff, but let's go down in here and let's get main working again, and then we can hash out any syntax errors. So we're no longer using a class, so let's remove that statement. But the rest of these are fine. We still need this degree increment here. We still need to reset the angle. And then down here, we're not going to do a change angle. We'll just use current angle. Current angle's already in degrees, so we can just take that statement out. We can use the same formatting. Current angle's still fine. Now my get sign's not part of my class anymore. And also, since I'm not passing the angle one time to my class, I'm going to have to pass the angle to each of my functions. So to do that, I'm just going to put current angle here inside the parentheses. I'm going to do the same thing here with get cosine. And I'm going to do the same thing here with get tangent. And then we'll run it and see what kind of syntax errors we have, or if it runs. Okay, let's see what else maybe got messed up. Okay, it looks like it's still working. So let's do 0 to 90 and do 91. Okay, and everything's still working fine, so I didn't introduce any syntax errors into this. So let's take a look at this again. So before we had this class and we had all the private data in there, it definitely made it a lot more complicated, right? So just like we talked about last week, your first reaction is probably, why in the world would I ever want to use a class? But again, the nice thing about a class is if you're working on a project with many different people, using a class really enables you to modularize or encapsulate that code so that the code that you're programming doesn't affect the code that any of your other group members are programming, or vice versa, or minimally impacts it anyway. And then the other thing is you could create that class and then put that class in a file, and then anytime you needed to use trig functions and you wanted to reference them using degrees, you've got all that stuff built in and all in one package, and you could port it over. So again, it gives you that idea of code portability. But for a simple program like this, class is really just going to make your programming a little bit longer, a little bit more complicated. So if you feel that it's doing that, you're absolutely right, but just think of it as a way to kind of practice for when you write more complex programs with a lot of people. Okay, you can see that with functions, functions allowed us to pull out the formulas and place them up here. You could argue that that made it a little bit more complicated than just having the formulas down here, but I think you could see the benefit when you look at this statement down here. It made this statement really nice and clean. We didn't have to have either a calculation right in the cout statement, which would have made kind of a complicated formatted cout statement even a little bit more complicated. The other choice would have been some extra lines of code in here where we declared some additional variables for sine, cosine, and tangent. We had our calculations up here. But then that buries our calculations down deep in our program, and that makes it a little bit harder to go in and change them. So hopefully you can see the benefit of using the functions here, that it's made your formatting a little bit clearer to see. It's made things a little bit easier to work with down here. And also it's pulled all your formulas out into one place so that if you have a problem with the formula, or you need to change it, or you need to add capability, you've got everything in one place, and so it's a lot faster to go back and make those changes. Well, thanks for watching.